So how does it work when it comes to bagging? Bootstrap aggregating. Say you have a training data set. Okay. Whenever we have data, we know for a fact that we need to split that data into training and test. So say you have output variable and input variables. You have some data, 10,000 observations. What do? You randomly split this data into training data set and test data set. Okay. Randomly we are doing this. Randomly we are splitting the data into training and test. And then what do? You build your model on the training data. This building the model is called as a base learner. The baseline model that we are building. Then once you build your model, what do? You test it on the test data. When you test it on the test data, there are multiple ways of combining the results. One is, do you want to combine the results of overall accuracy, or say 20% of 10,000 will be how many observations? 2,000 observations. Say observation number 1, output is, will a person default or not? Say you have inputs. So the last one is not there. Say you have the inputs. When we give these 3 inputs to your base learner 1, base learner 1 will give you some result that, okay, person will default. So base learner 1 is giving you an output that person will default. Keep the result like that. Now what happens here? Bootstrap sampling is going to happen. What do you mean by bootstrap sampling? Sample with replacement. So again, you split this data into training and test. And then build a model once again on this. When you build the model, you use base learner, another base learner that is called as base learner 2. Same decision tree. Here if you use decision tree, and here also if you use decision tree, etc., it will be called as homogeneous ensemble technique if you use the same set of algorithms. And then once again test it on the test data. When you test it on the test data, for this observation number 1, maybe you get a different result altogether. Maybe base learner 2 might say that result is not default. Again, in that way, again split the data, and then you get base learner 3. Again, you test the data, you get base learner 4. But remember one thing, that the test data will remain the same. This will not change. Test data will remain the same always. First time you split, right, training and test, you have the test data will remain as is. The only thing that will keep changing is your training data. Okay. Even when you split, forget about test, only take train the model. Then test it on this test data only. Only then for every observation, you can test it using different algorithms, different base learners. Otherwise, if the test data is also different, then how would you look at predictions for this observation 1? Within this first split, maybe in test data, you have this observation. In the other splits, you need not have this observation. This observation 1 might go into your training data. Hence, test data will remain as is. Your training data will keep on changing. And as in how you build the model, bring it and test it on this. Say base learner says that, 3 says that person will not default. Now you combine the results. How do I combine the results? What will be the final output for this? Not default, majority voting. Voting happens, hard voting happens, majority voting, right? You vote the majority. So the final output will be person will not default. Instead of this, if the output variable is salaries of people, then base learner 1, you split the data, you train the model, build your base learner 1, test from the test data. For the person 1, it might so happen that salary will be 10 lakhs per annum. Then again split the data, take the training data, train your model, test it on this test data. Then say salary would be 900,000, 9 lakhs. This might say salary will be 11 lakhs in that way. So how would you combine the results? By taking an take average when you have numeric output. Take majority voting or hard voting when your output is, yes, when your output is categorical. Now there is, yeah. Yeah. Right. Yes. Training will change. When I split the data into training and test, are you saying each time I sample randomly and get data, will we get the same data always in training? Randomly I'm sampling. Oh, absolutely. Absolutely. No. It won't. Maybe you might feel that this observation might be getting trained multiple times, but do you know what? So is the case with the other observations also. All the other observations of first test split might start appearing in training data. That's fine. Okay, this is one part of the story. So now you understand averaging. You also understand voting. Done.